have Wisława on, and I'm just going to introduce, hello, and I'm just going to introduce with the brief bio here. Wisława Osenska is an associate professor at the Institute of Information and Communication Research of Nicholas Copernicus University in Torun, Poland. She has a physics background, received a PhD in information science. Her research interest concerns widely understood information visualization methods, and in particular, science mapping and visualization. She coordinated national grants and participated in international research networks, such as the COST network, analyzing the dynamics of information and knowledge landscapes. She currently works in the CHIST ERA, and she is a member of ISKO, and maybe she can tell us a little bit about these two, Polish chapter and Polish Computer Science Society. And we'll post a link to the website as well for that. So I do want to say, hey, good to see you. And thank you so much for participating. And what I'm going to do is I'm just going to turn the floor over to you, and I'll sit back and listen. So thank you once again.
Thank you. Good afternoon and good morning for Americans, British. Thank you very much for inviting me to this 24 hours event about science mapping. Thank for inviting to all organizers and Katie particularly. I'm going to present about my experience in science mapping, including our last projects, local projects, and my newest book about science maps. Let me to share my screen. I'm not only Places and Spaces ambassador in Poland, but I'm also a researcher. So I present maps of science, but also design and teach how to make a good project of science mapping, of science maps. As a researcher, my interests are mainly in information and the data visualization methods, science mapping, and also I do research in user experience, user interface design. As academic teacher, I provide classes on data visualization, but also database design, scripting in script languages, and also graphic design, animation design. I am also IT trainer, Places and Spaces ambassador in Poland, and my main interests outside the science are oil painter, I'm film fan, and tourist before COVID pandemic. Okay, let's start from my beginnings of science mapping. When I received PhD in 2009, I mapped data from ACM digital libraries. I successfully scraped data from this portal of ACM digital library. Successfully, these documents were classified, and it gave me a possibility to count common categories of these documents. Today I know it called co-categories method or co-categories counting, and giving this similarity method, similarity way, I selected output space as sphere, surface sphere, and mapped all documents keeping this similarity method to surface space. And here, this is the formula for flattening a final map for reducing the dimension data to output space. This technique is well known and called MDS plot, MDS techniques. It's quite simple among our community, but for me it was first technique I figured out, and it was my final final map of all documents from digital library, ACM digital library. This time I used MATLAB environment for the first experience was from mapping and clustering using MDS technique to sphere surface. And tools which I used related to MATLAB environment. I wrote scripts in MATLAB environment. Later, I presented some cartographic projections of this sphere to the flat map and gave such complex patterns. After graphic filters, I received more, maybe more clarify map, or more attractive, I would say. And this is a map of keywords from the same data. Why I took the topic about my first experience, because my road to science mapping was started from clustering, not from linking of documents or network science or graph theory. That time, 11 years ago, 12 years ago, I have no knowledge about network science, graph theory, or SNA, any tools. I just scraped data from portal and made clustering, finding very good technique for my data like MDS. Of course, next years I completed my knowledge in scientometrics and network science, and extended my experience with mapping of science. Taking into consideration my experience, I can divide all science maps I met on two such main categories: graphs and scatter plots. Like scatter plots, I mean maps, the map which consists of a lot of points scattered. I found Jan van Neck and Wortman called these categories like link-based and distance-based maps. They also divided into two main categories science maps. But according link-based, I'm agree. This is good. This is good name. But according distance-based map, I would. I have some objections because in algorithms of mapping graphs, in graphs algorithms, distance is sometimes this algorithm give us distance as output, and this is sometimes this we cannot differentiate distance-based and graph-based maps, because in graphs distance is always a measure, a key measure. According to my observation and research, first category is more suitable for relationship between people, for the items which alive. When we put ties between people, when we measure relations between people or some alive items, then it is more appropriate to use links. But for science maps with domains, representation of disciplines, is dots are more appropriate or more frequently used according scientific literature. This is my observation. So I would differentiate name for first category is sociography, because this first category measures relationship between people and looks for patterns of collaborations. And for second category, I would choose Garfield's famous name, scientography, and remind this forgotten term for today, scientography and sociography. This illustration was taken from my US book. Here is and here is a cover of this book, published just this month, December 2021. And the title of this book, Science Map, Research Potential and Challenges, Challenges by Exams, where I, in this book, I presented many own exams. I can translate main chapters where I considering definitions. In first one, I considering the definition of science maps, especially I discuss about differences between maps and graphs, and try to answer on questions. Is any visualization become science map if we use data about science? In the second chapter, I draw milestones of science mapping, such historical review, and main guide for me was Katie Borner Atlas of Science, especially GigaPan timeline, interactive GigaPan timeline where we can read each map, zooming in any resolution, study in any resolution on this in this interactive application. In next chapter, I explain how to design science maps. How to design, I introduced to the main tools are known in our community, and compare these tools and environments. In the next, I introduced to method and techniques of visualization, especially types of analysis and scales of analysis, visual analysis. In next one, I published some textual maps, science maps, using natural language processing techniques. In the last one, I discussed about evaluation of science mapping, of course, especially with relation to the last problems which were presented on last scientometrics conferences, like is map reproducible in any case. This is a presentation, very short presentation of my book. Of course, I put some visualization of literature I use in this book. For example, I made timeline of all sources I used for writing, and we can see their bibliography is quite new, from 2000 mainly. The scope of published books is from 2000 to 2020, but the first are from 1965. It's prize books. And another illustration, network of authors in bibliography. Of course, Shen, Jaume Shen, and Borner, and Boyack, Waltman, all main authors among science mappers are here. Another questions I put in my research is how science maps can help to individual researchers, or maybe group of researchers for evaluation or for evaluation of these researchers. Thinking about these questions, I initiated several projects, but local projects. The main problems we met in Poland, there is no central bibliographic database. This is very difficult to map if we have no data, big data, or maybe not big data, large scale data. So we can use, in this case, we can use local bibliographic database. And I used our local university database called Expertus. Here is general description of one record, and we can see here main basic metadata of such bibliography, like year of publisher, authors, title, journal, formal, some description, what more, but also punctuation of our ministerial of our ministry. This punctuation mainly is reference to impact factor, but not also, but not only. Of course, they took into consideration several databases of journals, like SCImago database and evaluation by SCImago, according SCImago. Also, very they differentiate according disciplines, domain and disciplines, and try to introduce the weights between disciplines. It was valuable data for mappers. So we took the data from Expertus and designed such visualizer. We called it scientific output visualizer or scientific visualizer, generally used for microanalysis, micro-encoding classification, micro, meso, and macro. And now I want to present this application. I turn to go to another card, my card on my computer, and need your confirmation. You see my screen?
Yes.
Yes, thank you very much. This is the main window of this application. All maps, 6 maps, we see 6 maps are no colored because there is no data. By clicking this button, upload file, we can upload the file records of particular researcher. I have just uploaded files of our famous researcher at our university, Władysław Duch, who is computer and cognitive scientist both. Some colleagues asked me, why will you use upload file button instead of linking to the database? According to me, this is this strategy has such a goal, how researchers to analyze textual data of their records. They should go to database, click on their records and download our records in textual file. And after they should upload this file to this application. According to me, it can educate researchers and force them to teach about data, about records, own records. Okay, let's see first map. This is typical, sorry, I should input and repeat all steps. Yes. The first chart is dynamics of all publication from the first year of publishing to the current. This is typical bar chart, and I can switch to English. Sorry. Yes, to go again. And this is a typical stacked bar chart, and differentiated by colors categories of publication, like book, chapters of book, articles, review, and other. And we see that this researcher mainly publishes articles and chapters in books. So this is classical, I would say classical chart. Another one is collaborated graphs. It's amazing, and any researcher can evaluate collaboration community by looking at the density of this graph. Here we build some metrics based on input data, according as the very important first year of publishing, of course, count worked, ministerial points, summary, average, sum of co-authors, impact factors, what more? Ratio of papers written in English to Polish. For us, it's very important, especially if we analyze local data, and most collaboration with. Next graph is a map where we mapped the data about publishing place. Publishing place, which was extracted from the data, and we used Google Maps for plugin for this mapping. So any researcher can evaluate own scope, geographic scope of publishing. Next is a bubble chart with ministerial points of works, and here is scaling factor. Vertical axis is ministerial points, but of course you can ask what is bubble size here. Bubble size is pages now, number of pages. It's such interesting nuance for researchers. Next is keywords maps, both separate for languages in Polish and in English, with a threshold level. These maps are, of course, the main recipient is researcher, but sometimes researchers want to compare themselves with colleagues or with chief or dean, so they can upload any separate file of from local database experts and analyze each researcher separately. This is the main idea, micro level, without any comparison. comparison you make in your mind, not some averaging, not benchmarking of group of researchers, only individual level. The highest challenge was combined with this chart. In primary conception, it was a ring where we put all disciplines and domains according to science classifications. And according to this conception, we want to put all points, means all articles as points in this space. But unfortunately, this space was limited for these purposes. And I can go to the current conception, how to solve this problem. Disciplines map of our output. Let's go to my presentation back. This is a view of previous conception, the same researcher and his disciplines. Here is science, here is yes, science and computer science, elite engineering, and this is medicine. So his interests are around these domains, mainly in science, computer science, and around medicine and engineering. But this is not enough. This space was not suitable for our purposes, and our next conception is to use this map, famous map of Polish scientific journals. I published this in, made this in two years ago and published in the Journal of Information Science this year. Why this map is beautiful, I would say, because I received very good clustering parameter. I mapped all, not all, but main Polish journals, 4,000 Polish scientific journals by t-SNE algorithms and gave very nice results. If we introduce a color for any class of domains, according to science classification, there are 8 domains. When we see a very good coherence within any clusters, within any color, any points is some journal, which belongs to one or more disciplines. And t-SNE map, t-SNE algorithm is a very good solution for this data, because we see by coloring there is a very high precision of this clustering. Maybe single cases are belongs to outsiders, some outsiders to cases with bad clustering, but there are only few such cases, like here or here. Generally, this is very good clustering. Of course, some skeptics can ask, t-SNE, you can, why you so exciting? You can take another data and t-SNE will solve this problem. Let's see, the same clustering, with, and also journals all journals from ministerial list. This is 48,000 of journals clustered by Disney. And we found there is no such coherence, topical and domain coherence like in these examples. Another example, Disney again, for Cora database. It's quite old database. Examples from of computer science articles. And we see how Disney algorithm clusters. If it cannot find solution for clustering, it put the points to coming back. This is a part of data being clustered, but the majority are unclustered. So I show these examples to prove that this case good matching between data structure and clustering algorithms. Okay, I was talking about individual macro individual micro level of science mapping, and let's consider the next level, meso, where we want to evaluate a group of researchers. For this purpose, we take such diagram for SWOT analysis. Usually in management science, this diagram is very useful when we want to see the strengths and weaknesses of society or production. Strengths, weaknesses, opportunities, and risks. SWOT analysis. There are 4 quadrants, 4 areas. And we took this conception of diagram for our mapping, science mapping. On a horizontal axis, we put all effects of researchers, points by ministerial points for ministerial list. On vertical axis, we put potential weights. We considered some grants, financial abilities, a collaboration with international collaboration, and many more factors, and created such graphs, interactive graphs, and I can show this application in separate window. I hope I can jump to this application. It's here. Portfolio research. Yes. Of course, again, we choose upload the file. This is interface of this application. There are 4 quadrants. In this quadrant, the most potential researchers and with the biggest effects, biggest number of points. This data are selected from separate faculty. Dean can move threshold of these quadrants. It depends on the decision of the criteria. These thresholds are movable. There are here is a list of researchers, and we can group. There are a lot of teams, and we can see, for example, if we take one researcher with members of teams. Yes. Of course, the worst potential is here. Worst potential and a group of researchers who needs to push to be pushed to the higher quadrants. This is local application for researchers' achievement evaluation, not for publishing, of course. Something like internal evaluation of within community of faculty. These exams show us if we do not have macro scale data, big data, we should focus on local data set and extract as more as possible from this data. Look at this data from various perspectives. This is what are the topic I figure out every time, and how to use data, having a small amount of data, small and limited number of fields. Another observation, for engaging the user to analysis, microanalysis, meta-analysis, science maps should be interactive. But if we cannot make interactive application, then we should combine different science maps on inter dashboards, like Google Analytics dashboard, and put on one layout as more as possible visualizations. I'm going to come to the end. This is my this is contact to me, and a famous photo made with my cat 12 years ago, how it played with science maps from my PhD PhD balls. Okay, thank you.
Thank you so much. I just had just a follow-up question. You mentioned that one of your passions is doing oil painting. Do you is that connected in with your interest in science mapping, or how do those two overlap, or do they?
Yes, thank you for questions. Yes, science mapping, according to me, this is a combination of technical skills with aesthetical value, right? And if you have experience with graphics, drawing, it can help you to make beautiful visualization, because in the visualization process, graphic matching graphics is the last phase of such processes. In a final stage, you need to see on visualization by user eyes, by how user look at this visualization. So this experience is very helpful, and always I try to evaluate these maps myself, and with discussing with my colleagues, have to have, but always I try to look as artists at final visualization. So technical level and aesthetical level are the most essential for me, but also we need to take into consideration some contextual social context of science map, or thematic context of science map. Always from yes, first of all, technical aspects and aesthetical, but also context of science mapping, I would say this way.
Thank you. You know, I first encountered your name as one of our ambassadors for the Places and Spaces exhibit. And I'm a co-curator, and I've been involved with the exhibit since around 2012. I was looking through some pictures, and I believe that it was that you hosted it in 2010. Is that right? Was it, or 2011? Was it about 10 years ago?
Yes.
And how did you first become aware of the Places and Spaces exhibit?
It was in Amsterdam when I was participated in a coast meeting where Scharnhorst invited me to this meeting, and I met Katie Borner face to face, because primarily I cited her articles only, but it was occasion to speak with her, and she proposed me to become ambassador, and I was very, very happy. And of course, all posters, because I have collection of posters of all iterations of Places and Spaces, presented on conferences in Poland, on many conferences in Poland in this period from 2011 to 2018. So the exhibition were in majority of Polish cities, were in academic cities, at university was presented.
Yeah, and you were instrumental to that. We absolutely love our exhibit ambassadors, and they do so much for us about finding opportunities to present places and events to show the work that we do with the exhibit. So a huge thank you to that, and congratulations on the publication of your book. what was the experience of writing that like? How long did that project take? I saw at the beginning you showed the timeline of citation works that were cited, but how long have you been working on this particular book, and what was the experience of writing something like this?
Mhm. Do you mean how long did I work on book text or on visualization?
The book text itself, yeah.
On book, it was taken about 2 years. 2 years. So.
And the project itself, in terms of when did you start thinking about, or kind of in your head putting together the book's project?
When the conferences I was participated, like ISSI or another good place for such conception of books. The conferences and beautiful visualization, interactive visualization. When we find some new kinds of visual representation, especially interactive, when we can play with this, the conception about grouping method or classification, how to classify this new visualization to old ones, how to compare, was born, and this is good step to think about some systematize our knowledge. So conferences and a new interactive visualization are main stimuli for me for writing books.
Yeah, and I was wondering too, if you were to give advice to someone who had an interest in science mapping and were getting started, your book might be a resource. You mentioned also looking at beautiful visualizations, looking at good examples of that. First, what advice would you give someone starting off in science mapping? What should they be paying attention to? What classes might they take? And then also, where does one find, where are some good resources for finding visualizations that are both technically astute, technically accurate, but also that merge the data and the artistic aspect of it in a very good way?
Usually, I start from Places and Spaces portal. It's nice you put news there, some novel new visualization, where usually in the scientific articles, authors put information about sharing their research on GitHub. This is also a good way to find something new. Another source are some common known portals, like website like flowing data or raw data. Do you know? You should know raw data. Yeah. Raw graphs. Made by Milano Technical University. They develop very intensively this portal, and they put a sources code to visualization. Systematically, when we systematically check this information in favorite places, we can complete our knowledge and find always something new things for research, for comparing, and for teaching students, to show to students. So the portals and articles.
Thank you so much for giving giving up an hour of your weekend at a very busy time of the year, I'm sure. And thank you for your inspiring words and for being a part of this. And we really appreciate you as an ambassador. And and once again, congratulations on the book. So thank you so much.
Thank you very much, Todd, and all organizers. Thanks.